A star tears across the void, moving faster than the galaxy itself can hold. These are hypervelocity stars, cosmic projectiles flung from the centers of galaxies, and they are sending us signals we cannot explain. By the end of this journey, you will know the 25 most baffling cosmic messages that defy everything we think we know about the universe. Why would a stellar corpse emit a complex, structured pulse? What could cause a signal to vanish without a trace after years of transmission? We are about to dive into the evidence that has astronomers questioning the very laws of physics. What do you believe is waiting for us in the dark between the stars? The first signal arrived not as a whisper, but as a scream echoing from the void. Astronomers tracking a star fleeing our galaxy at over 1 million miles per hour detected a powerful, repeating radio burst locked to its position. This was not a random cosmic crackle. It was a precise, rhythmic pulse with a frequency pattern that defies all known catalogues of natural events. It does not match the dying breath of a collapsed star, the spin of a pulsar, or any form of human technology. The sheer regularity of its outbursts points to a source of immense power and stability, something anchored to the star itself. One leading theory suggests this hypervelocity traveler might be interacting with a previously unseen form of dark matter. As the star plows through the galaxy's halo at incredible speed, it could be stirring up this mysterious substance, causing it to release energy in these brilliant, predictable flashes. Another idea posits a completely unobserved stellar phenomenon, where the star's own magnetic field, stretched and contorted by its velocity, is generating these bursts like a cosmic lighthouse on a runaway journey. The very existence of this signal forces us to confront a profound question. What kind of natural engine attached to a single star could produce such a clean, repeating signal across such vast distances? The answer remains locked within those rhythmic echoes, a message from a messenger that will not slow down to explain itself. Its mathematical purity is what makes the second signal so deeply unsettling. While tracking a runaway star flung from a supernova explosion, a radio observatory in the Chilean highlands recorded a transmission of breathtaking elegance. It was not a simple pulse, but a cascade of frequencies, a harmonic series so perfectly stable it resembled a chord played on some cosmic instrument. Each note in this whisper from the void was a precise mathematical multiple of a base frequency, a structure far too clean to be the chaotic aftermath of a star's death. Pulsars, the spinning remnants of supernova, produce rhythmic ticks, but they are messy, often wavering and prone to glitches. This was different. This was a perfect, sustained chord held for years, a signature that instrumentation error or any known stellar process simply cannot forge. The sheer precision of this harmonic whisper has ignited a fierce and ongoing debate. One camp of astrophysicists argues we must be witnessing a completely new form of stellar oscillation, a natural resonance in the star's atmosphere or magnetic field that we have never before observed. Yet the signal's artificial appearance is difficult to ignore. Could it be a beacon? The idea that an advanced civilization might place a transmitter on a star destined for a galactic ejection is a staggering thought. It would be a message in a bottle of unparalleled scale, launched across the galaxy on a permanent trajectory. The community remains divided, caught between the need for a natural explanation and the haunting possibility that we are listening to an engineered signal, a deliberate broadcast from a traveler on a one-way trip into the intergalactic dark. This cosmic chord was soon joined by a signal of pure, chaotic power. The third signal on our list arrives not as a melody, but as a violent flash in the X-ray spectrum. Imagine a lighthouse that only flashes at random, unpredictable intervals, but when it does, its beam is blinding. That is the nature of this intermittent X-ray beacon, emanating from a hypervelocity star speeding through the sparse matter of the galactic halo. These are not gentle pulses. Each burst unleashes an immense amount of energy, enough to be detected across vast intergalactic distances, yet they come without any discernible rhythm. One month might see 3 flashes, the next year could pass in total silence. This sporadic behavior and the sheer power involved completely defy our current models of stellar physics. Standard explanations like accretion, where a star pulls in surrounding gas, or magnetic reconnection, where magnetic fields snap and release energy, simply cannot account for the irregular timing and the ferocity of these outbursts. The leading natural theory suggests the star might be plowing through dense, invisible clouds of interstellar material. As the star rams into this gas and dust at millions of miles per hour, the violent collision could, in theory, generate these intense X-ray flashes. But there is a critical gap in this explanation. The observed energy output is orders of magnitude higher than such collisions should produce. Furthermore, the distribution of interstellar matter is not clumpy enough to explain the extreme randomness of the signal. Why would the flashes be so wildly intermittent if the star is moving through a relatively uniform medium? The beacon's erratic nature and impossible power leave us with a profound mystery, a runaway star that seems to periodically unleash a scream of energy that our science cannot yet translate. The erratic X-ray beacon is not the only light-defying explanation. Our fourth signal was discovered not in a burst of energy, but in a subtle, mysterious twist of the very light we see. Astronomers analyzing a particular hypervelocity star noticed something strange about its visible light. The light waves were not vibrating randomly in all directions, as is typical from a star. Instead, they were strongly polarized, meaning the waves were aligned in a specific, coherent pattern. This by itself is not unheard of, as interstellar dust or magnetic fields can polarize starlight. But this pattern was too perfect, too organized. It did not have the messy, scrambled signature of light passing through a cloud of cosmic grit. It was a clean, structured signal embedded within the starlight, a deliberate fingerprint that natural processes struggle to replicate. To understand this, picture a calm, sunny day. The light from the sun vibrates in every direction. Now, imagine putting on a special pair of sunglasses that only let through light vibrating vertically. That is polarization. What astronomers found was like a pair of cosmic sunglasses permanently fixed to this star, creating a polarization pattern of impossible clarity. So what could be causing this? One compelling theory points to an exotic form of matter. As the star races through space, it might be passing through a diffuse field of theoretical particles like actions. The interaction between the star's light and this invisible field could, in principle, imprint this highly organized polarization. It would be like light passing through a universal filter we never knew existed. Yet the precision of the pattern also invites a more profound and unsettling possibility. Could this be a form of technology? An advanced civilization might use polarized light as a form of interstellar communication, a beacon far more energy efficient and subtle than a powerful radio blast. They could engineer their star or a structure around it to broadcast this polarized signal across the galaxy. It is a message written not in sound or code, but in the fundamental orientation of light itself, a whisper on the photon wind that only a technologically advanced species would think to look for and recognize. The true nature of this signal remains one of the cosmos's most elegant and frustrating puzzles. The fifth signal introduced a slow, creeping mystery. While monitoring the radio signature of a distant hypervelocity star, researchers noticed its primary frequency was not stable. It was drifting. The pitch of the signal was very gradually changing over time, sliding up or down the radio spectrum in a subtle, inexorable glide. At first, scientists assumed this was simply the Doppler shift from the star's own incredible velocity, the same effect that makes a siren's pitch drop as a police car races past you. But when they calculated the expected shift from the star's known speed and trajectory, the numbers did not match. The drift was there, but it was wrong. It had its own separate, additional component. The immediate suspicion was a problem with the equipment itself, a slow instrumental drift as the sensitive electronics aged or were affected by temperature changes. Teams spent years cross-referencing data from multiple observatories across the globe, meticulously ruling out this possibility. The drift was real. It was a feature of the signal, a temporal characteristic that meant the source of the transmission was not static. It was itself changing or moving in a complex way that we cannot yet see. Imagine a tuning fork that, all on its own, very slowly changes its note. That is the level of strangeness we are confronting. This temporal drift points to a dynamic source. Perhaps the object generating the signal is orbiting the hypervelocity star in a tight, decaying spiral, its motion adding that extra, unexplained shift to the frequency. Or maybe the signal generator itself is undergoing an internal transformation, its fundamental properties evolving so slowly that from our perspective, it simply appears as this constant, subtle drift. If this phenomenon is confirmed to be a natural process, it forces a dramatic expansion of our physics. We would have to accept the existence of a new, long-term astrophysical process, one that can gradually alter the fundamental frequency of a cosmic beacon over years or decades. This is not the violent physics of a supernova, but something far more patient and deliberate, a slow dance of forces we have not yet learned to see. The sixth signal arrives from a pair of stars locked in a frantic dance as they flee the galaxy. This hypervelocity binary system emits a series of pulses that, when decoded, reveals a pattern that sent shockwaves through the scientific community. The pulses are not random. They are spaced in intervals that correspond to a sequence of prime numbers, 2, 3, 5, 7, 11. The mathematical primes continue, a simple numerical code embedded in the cosmic noise. This is the binary code candidate, and it stands as one of the most hotly debated mysteries in modern astronomy. The argument for a natural explanation is rooted in the immense power of chance and the sheer size of the universe. Skeptics argue that with countless stars and an endless cacophony of emissions, it is statistically possible, however improbable, for a natural process to mimic a simple mathematical sequence by pure coincidence. Perhaps the complex gravitational interplay between the two stars, their magnetic fields whipping around each other, creates a resonant frequency that just happens to pulse at these precise intervals. The scientific community's skepticism is not just caution, it is a rigorous defense of the principle that extraordinary claims require extraordinary evidence. They point out that we have only begun to listen to the cosmos, and our search for patterns is inherently biased. We may simply be finding order in the chaos because our minds are wired to look for it. Yet the counterargument is profoundly compelling. The probability of a natural cosmic process spontaneously generating a clean, sustained prime number sequence is astronomically low. Prime numbers are the fundamental building blocks of mathematics, unique in that they are only divisible by themselves and one. They have no obvious utility in astrophysics, but they are a universal concept, a logical starting point for any civilization attempting to announce its existence. This is not a complex message, but a beacon, a cosmic handshake designed to be recognized as artificial. It is the kind of signal you would construct if you wanted to stand out against the background roar of the universe to say, "We are here." The debate forces us to confront a fundamental question about our place in the cosmos. Are we simply witnessing a one in a billion fluke of nature, or are we, for the first time, seeing the shadow of another intelligence, a message stamped onto a pair of runaway stars destined to travel the void forever? The prime number debate was suddenly overshadowed by a discovery of pure, violent coincidence. Signal number 7 connects a whisper to a scream across the entire electromagnetic spectrum. Deep within a neutrino observatory buried under the Antarctic ice, sensors recorded a fleeting burst of ultra-high-energy neutrinos. These are the most elusive ghosts in the universe, particles with almost no mass that can pass through entire planets without a trace. Detecting even one is a rare event. A coordinated burst of them points to a cataclysm of unimaginable power. At the exact same moment, down to the millisecond, a radio telescope in New Mexico recorded a sharp, unique radio pulse. Its origin was traced back to the position of a known hypervelocity star, one already under observation for its unusual speed. The correlation was immediate and precise. This was not a chance alignment. One event was the detection of the universe's most penetrating particles, the other a radio shout from a star fleeing the galaxy. They happened in perfect, terrifying unison. The significance of this cannot be overstated. To produce ultra-high energy neutrinos, you need a particle accelerator of cosmic proportions, an event so violent it can slam subatomic particles together with forces far beyond anything we can create on Earth. Supernova can do this, or merging black holes, but for that same event to also produce a coordinated radio emission, and for that entire package to be linked to a single runaway star, defies all known models. It suggests a unified engine, a single, unknown astrophysical process that can simultaneously accelerate particles to nearly the speed of light and generate a clear radio signal. Imagine a cosmic bomb that explodes and, at the very instant of its detonation, also blows a distinct musical whistle. We understand the bomb, but the whistle makes no sense. What natural phenomenon could be so efficient, so multifaceted? This coincidence is considered too significant to ignore because it points to a gap in our understanding of fundamental physics. We are likely witnessing a new class of event, a hypervelocity engine that operates on principles we have not yet discovered, a machine of nature that leaves its signature in both the deepest foundations of matter and the waves of space itself. The eighth signal arrived wearing a perfect disguise. Astronomers analyzing the light from another hypervelocity star identified a set of sharp, dark lines cutting across its spectrum. These spectral lines are the fingerprints of the universe, each one corresponding to a specific chemical element absorbing light at a unique wavelength. At first glance, the pattern looked familiar, like the signature of hydrogen or helium. But when researchers tried to match the lines to any known element on the periodic table, nothing fit. The lines were all shifted, but not in the uniform way caused by a star's motion. It was as if someone had taken the fingerprint of a known element and stretched it in a strange, non-linear way, creating a spectral signature that should not exist. The scientific response was exhaustive. Teams around the world attempted to recreate the lines in laboratory plasma chambers, subjecting every element to extreme temperatures and pressures that mimic stellar interiors. They tried exotic molecules and even theoretical compounds. Every single experiment failed. No known state of matter, under any condition we can create, produces this specific set of lines. This spectral imposter points to a reality where our map of the elements is incomplete. The most compelling theory is that we are seeing the signature of a new, exotic form of matter. This could be strange matter, a theoretical substance composed of quarks not found in ordinary atoms, or a super-dense element that is stable only in the intense gravitational field of a hypervelocity star. It might even be evidence of dark matter interacting with normal matter in a way we have never before observed, leaving a ghostly imprint in the star's light. Each of these possibilities requires physics beyond the standard model, the very rulebook for particle physics. This is not just an unidentified line, it is a direct challenge to our understanding of the fundamental building blocks of everything. The imposter's true identity remains hidden. A cosmic forgery that proves something profound is missing from our periodic table. The ninth signal tore through the fabric of space-time itself. In September 2015, the LIGO Observatory made history by detecting the first gravitational waves, the ripples from two black holes merging over 1 billion light-years away. The signal was a classic chirp, a rising frequency that ended in a silent merger. But something else happened. At the precise moment of that cosmic collision, a space-based telescope recorded a brilliant, fleeting flash of gamma rays coming from the same region of the sky. This was shocking on its own, as black hole mergers are not supposed to produce light. The mystery deepened exponentially when the source of that gamma ray flash was pinpointed. It did not originate from the merging black holes. Instead, it was traced to the location of a known hypervelocity star, a solitary traveler that was, by sheer coincidence, passing through that exact corner of the universe at that exact millisecond. The odds of such a random alignment are so infinitesimally small as to be practically impossible. This gravitational wave chirp companion presents an immense puzzle. A hypervelocity star is a runaway stellar projectile, not a participant in the cataclysmic dance of black holes. It should have been a silent bystander, a speck of dust near a detonating bomb. So why did it flash? The leading theory is that this was nothing more than a once-in-a-universe coincidence. Perhaps the star was simply in the wrong place at the wrong time, and an unrelated event on its surface, like a massive stellar flare, happened to go off at the exact moment the black holes merged. But this explanation feels deeply unsatisfying, a stroke of cosmic luck that defies belief. Another, more radical idea suggests the star was not alone. It might have had a hidden, compact companion, like a neutron star or a small black hole orbiting it. The gravitational waves from the distant merger could have, in some way we do not yet understand, agitated this companion, triggering a sudden and violent release of energy that we saw as the gamma ray flash. The most profound and unsettling possibility is that the star itself was the trigger. Could the gravitational wake of this hypervelocity star, as it plowed through the interstellar medium at incredible speed, have somehow destabilized the binary black hole system, nudging them just enough to cause their final, fatal spiral and merger? This idea turns our understanding of cause and effect on its head, suggesting a single star could act as a pin that pops a cosmic balloon. The chirp companion forces us to confront the uncomfortable idea that the universe may be far more interconnected than we ever dreamed, where a solitary traveler can whisper and two black holes answer. That profound silence from the ninth signal was a prelude to an even deeper quiet. The 10th signal on our list is defined not by what we heard but by what we stopped hearing. For years, astronomers had been tracking a specific hypervelocity star known for its persistent and unusual radio emission. It was a constant, stable feature of this cosmic runaway, a reliable whisper in the data streams of observatories around the world. Then, one day, it was gone. The signal did not fade away or sputter out. It vanished completely and abruptly, as if a switch had been flipped. One moment it was there, the next there was only the empty hiss of background static. The immediate assumption was an instrumental failure, a broken cable or a software glitch, but frantic follow-up observations confirmed the astonishing truth. The star itself was still there, shining brightly in the visible spectrum, completely unchanged. Its light output, its temperature, its velocity, everything about the star was exactly the same as before. The only thing that had changed was the anomalous signal. It had been silenced. This sudden spectral disappearance presents a baffling scenario. If the signal was caused by a natural, ongoing process within the star or its immediate environment, it should not simply cease without a trace while the star itself remains utterly unaffected. A catastrophic event like a massive asteroid impact or an internal stellar quake could explain a sudden stop, but such an event would have left some visible scar, some change in the star's light or behavior. We see nothing. This leads to a more unsettling line of thought. Perhaps the signal was not a natural process at all, but something external. One hypothesis suggests the source of the emission was a piece of advanced technology orbiting the star, a probe or a beacon of some kind. This artificial source could have suffered a critical failure, or perhaps its power source was finally depleted after millennia of operation. Even more provocative is the idea of a deliberate shutdown. Why would a transmitter be turned off? Was its mission complete? Did its creators, whoever or whatever they might be, decide it was no longer necessary? The silence itself becomes a form of message, a negative space that speaks volumes about the potential for a controlled, intelligent origin. The mystery of the 10th signal is a lesson in cosmic impermanence. We are left staring at a perfectly normal star, haunted by the memory of its strange voice, wondering if we were listening to the final broadcast of something or someone that has now gone permanently quiet. The profound silence of the vanished signal was shattered by a cosmic drumbeat. Our 11th mystery connects one of the most energetic phenomena in the universe to a single, speeding star. A repeating fast radio burst, an FRB, has been definitively traced to the position of a hypervelocity star. Fast radio bursts are millisecond-long flashes of radio waves that release more energy than our Sun does in 80 years. Most appear once and are never heard from again, their origins lost in the depths of space. But this one is a repeater, firing off its immense blast again and again, and it is locked onto a star that is moving at a staggering velocity across the sky. This is a potential game-changer because for the first time we have a specific, identifiable object to study, a culprit for these cosmic explosions. The leading theory suggests the hypervelocity star might have a dense companion, like a neutron star. As the two race through space together, the neutron star's intense magnetic field could be interacting with material stolen from the hypervelocity star, creating periodic, violent outbursts that we see as the repeating FRB. Another idea involves planetary debris. Perhaps this star is dragging along the shattered remains of its own planetary system, a vast cloud of asteroids and comets. When one of these massive chunks of rock falls onto the star, the immense impact could generate a single, powerful radio burst. But here is the problem with that explanation. This is a repeater. For the planetary debris model to work, it would require a constant clockwork supply of giant asteroids, all falling onto the star in precisely the right way to create identical bursts of energy. The sheer repetition defies the chaotic nature of such a destructive process. Even the neutron star companion model struggles to explain the raw power and the clean, repeating structure of the signal. These are not messy, sputtering bursts. They are sharp, clear, and terrifyingly powerful, like a cosmic hammer striking an anvil at regular intervals. The repetition itself is the deepest clue, pointing to a stable, cyclical engine of unimaginable force, one that is somehow hitched to a star on the run. This runaway star is radiating a warmth it should not possess. Our 12th signal is a ghost of heat, an unexplained excess of infrared light pouring from a hypervelocity star. The star itself, based on its size and temperature, should glow with a specific amount of infrared radiation. Instead, it is shrouded in a much brighter, invisible warmth, as if it is wrapped in a cosmic blanket that traps and re-radiates its energy. The immediate scientific suspicion fell on a circumstellar disk, a vast ring of dust and debris orbiting the star. Just as the sun heats the dust in our own solar system, making it glow faintly in infrared, this star could be warming its own personal asteroid belt. Another possibility is a hidden companion, a brown dwarf. These are failed stars, too large to be planets but too small to ignite nuclear fusion in their cores. A brown dwarf orbiting close to the hypervelocity star would be a significant source of infrared light, a dark partner contributing its own dull heat to the system. Yet, as observations continued, problems emerged with these simple explanations. The amount of infrared excess is immense, far more than a typical dust disk or a single brown dwarf should produce. Furthermore, the star's incredible velocity should have stripped away a fragile disk of dust eons ago, leaving it naked and exposed. The stability of the infrared signal, unwavering as the star races on, suggests a source that is not being eroded or left behind. This is where the investigation turns to concepts that sound like science fiction. One of the most profound and controversial explanations is the theoretical notion of a Dyson sphere, or more likely, a Dyson swarm. This would be a vast collection of energy-capturing structures built by an advanced civilization to entirely surround a star and harness its total power output. The waste heat from such an immense technological project would be radiated away as infrared light, exactly the kind of anomalous glow we are detecting. The idea is staggering to contemplate. Could we be witnessing a mobile power station, a star engineered by its inhabitants to provide energy as it voyages through the galaxy? The immense difficulty in obtaining clear data makes this mystery so frustrating. The star is distant, moving fast, and its infrared signature is a blur in our telescopes. We cannot resolve the source, we can only see the cumulative effect of its impossible warmth. We are left with a fundamental question. Is this the signature of a natural cosmic structure we have not yet imagined, or are we seeing the first, faint thermal footprint of a civilization so advanced it has built a shell around its own sun and set it sailing into the void? Signal 13 arrives as a slow, rhythmic breath in the microwave band, a deep, cosmic hum that pulses with a regularity that is both precise and deeply puzzling. This is not the frantic ticking of a pulsar. It is a slow, deliberate modulation, like a lighthouse beam sweeping across the cosmos with a patient, unwavering cadence. The star itself spins at a known rate, but this microwave pulse operates on its own separate clock, a period that does not match the star's rotation in any way. This disconnect is the heart of the mystery. A natural explanation points to precession. Picture a spinning top as it begins to slow down, its axis tracing a slow, wobbly circle in the air. The star itself could be undergoing a similar motion, its rotational axis slowly wobbling over a long cycle. If the source of the microwave emission is locked to this wobbling axis rather than the equator, it would produce a pulse with a period completely different from the star's spin. Another possibility involves a magnetic field of mind-bending complexity. Most stars have a relatively simple magnetic field like a bar magnet, but this star could possess a tangled, multipolar field with hotspots of intense activity. As the star rotates, these magnetic hotspots could swing into and out of our line of sight, creating the modulated signal we detect. Yet, the sheer stability of this slow pulse pushes against these natural models. Precession is often unstable, and complex magnetic fields tend to be turbulent, not perfectly predictable. This is where speculation enters a far more profound territory. Within SETI circles, this signal is discussed with intense interest because its characteristics are precisely what you would expect from a directed energy source. Imagine a civilization that has mastered the ability to push its star across the galaxy. One proposed method for such a staggering feat is a giant light sail, propelled not by sunlight but by an immense focused microwave beam. The slow, regular modulation we detect could be the beam itself, sweeping past our solar system as it pushes the star on its journey. Alternatively, it could be a form of communication, a deliberate, low-frequency broadcast designed to penetrate the interstellar medium with minimal loss. The modulation would be the data stream, a message encoded in the slow, rhythmic size of the microwave emission. The signal sits at the perfect crossroads of astrophysics and imagination, a phenomenon that could be explained by a new type of stellar wobble, or by the first evidence of a civilization not just looking at the stars but moving them. 14 on our list is a whisper of motion, a rhythmic sway in the light of a star that should be moving in a perfectly straight line. As this hypervelocity star flees the galaxy, its light exhibits a Doppler shift, changing color slightly as it speeds away from us. But buried within that predictable shift is a tiny, periodic wobble. The star is not just receding, it is swaying as if pulled by an invisible partner. The precision required to detect this wobble is almost beyond belief, demanding instruments that can measure changes in velocity smaller than a person walking. This minuscule dance points to an unseen object of significant mass, something locked in a gravitational embrace with the star. The immediate suspect is a planet. Yet the math does not add up. The inferred mass of this hidden companion is far too great for a planet, and its orbit is too small and tight. A planet with that much mass in that close of an orbit would be torn apart by tidal forces or would visibly disrupt the star itself. It simply could not exist under the known laws of physics. So what is pulling on this stellar runaway? One compelling theory is a stealth black hole. This would not be the supermassive monster at the galaxy's center, but a stellar mass black hole, dark and invisible, orbiting the star. Its immense gravity would easily explain the wobble, its darkness accounting for why we see nothing else. But even this idea runs into trouble. How could such a binary system survive the violent event that flung the star out of the galaxy in the first place? The forces involved in creating a hypervelocity star are cataclysmic, typically tearing binary pairs apart. Another, even more exotic possibility is a planet made of something we have never seen, a world composed of ultra-dense quark matter or a fragment of dark matter. This would be an object with the mass of a star compressed into the volume of a planet, a gravitational anchor of impossible density. The anomalous Doppler wobble is a ghost in the data, a signpost pointing to a massive, dark, and utterly enigmatic traveler, silently keeping pace with its stellar partner on a journey into nowhere. The star's invisible companion was soon upstaged by a flash of impossible coordination. Signal 15 erupted as a single, blinding instant of light. For just 3 minutes, a hypervelocity star became the brightest object in its region of the sky, not in one color, but in 3 distinct energies at once. A sharp radio screech, a brilliant optical flare, and a piercing X-ray spike all began and ended in perfect, terrifying unison. It was as if 3 different cosmic instruments, a bass drum, a cymbal, and a flute, all played a single, deafening note at the exact same moment, then fell instantly silent. The event triggered automated alerts across the globe, sending astronomers scrambling to pivot their telescopes, but by the time most were online, the show was over. All that remained was the data, a perfect multi-wavelength fingerprint of an event that should not be possible. No single known astrophysical process can release such a massive, coordinated burst across such disparate parts of the electromagnetic spectrum. A solar flare on our own sun, for example, might produce X-rays and radio waves, but the timing is messy. The components staggered as energy travels through different layers of the star. This was different. This was instantaneous. The leading natural theory points to a starquake, a seismic event on the star's surface so violent it could, in theory, shake the entire star and release energy in multiple forms simultaneously. Imagine a bell being struck. The impact creates a sound you can hear and a vibration you can feel. A starquake could be the cosmic equivalent, generating the optical flash from the sheer heat of the rupture, the X-rays from accelerated particles in the aftermath, and the radio waves from the shuddering of the star's magnetic field. Yet, the energy required for a quake powerful enough to produce such a brilliant, multi-wavelength flash is staggering, pushing the limits of what a star's structure can withstand without being torn completely apart. Another idea suggests an external trigger. Perhaps the star was hit by the shockwave from a distant gamma-ray burst, a cosmic tsunami of radiation that washed over it. This wave could have compressed the star's magnetic field in a single, violent instant, energizing it to release this coordinated flash. But this, too, feels insufficient. The flash was too clean, too perfectly synchronized across wavelengths that behave so differently. It hints at a single, unified engine, a process we have not yet named, capable of translating a single impulse into a symphony of light. The brief, brilliant life of that flash leaves behind a fundamental question. Was this the death rattle of a natural phenomenon we barely understand, or was it the synchronized ignition of something else entirely? A low-frequency radio hum from a distant runaway star reaches our telescopes with impossible clarity. This is Signal 16, a transmission that should have been lost in the fog of space. The interstellar medium, the thin soup of gas and dust between the stars, acts like a cosmic filter for low-frequency radio waves. It scatters and absorbs them, blurring distant signals into an incoherent hiss over vast distances. It is the same reason why you cannot pick up a distant AM radio station at night without static, only on a galactic scale. For this particular hum to arrive from a hypervelocity star thousands of light years away and still be so sharply defined, so clean, it defies the known properties of our galaxy's interior. It is like hearing a whisper from a person shouting from the other side of a raging waterfall, and hearing every word as if they were standing right next to you. This anomalous propagation forces us to consider two radical possibilities. The first is that the signal is using a physical principle we have not yet discovered, a way to tunnel through the interstellar medium without losing its coherence. Perhaps it is manipulating space-time itself in a subtle way, creating a path of least resistance that allows the signal to slip through the noise. The second, equally startling idea is that we are wrong about the signal's origin. What if it is not coming from the star itself, but from a point much closer to us, a relay or a probe that is somehow linked to that distant, speeding sun? This would mean the hypervelocity star is not the source, but a celestial landmark, a flag planted in the void to draw our attention to something else entirely, something that has been traveling alongside us, broadcasting a clear signal from just next door. 17 on our list presents a paradox, a signal that grows fainter when it should be stronger. Astronomers tracking a hypervelocity star noticed its unusual radio emission did something inexplicable. The signal's intensity was not constant. It dipped and faded at specific points along the star's path, and these dips corresponded with something invisible on our cosmic maps. When the line of sight to the star crossed through regions of space known to have a high density of dark matter, the signal weakened. It was as if the signal was being absorbed or scattered by the very substance we cannot see. This anti-correlation is a tantalizing clue, a potential interaction with the universe's greatest mystery. Dark matter is believed to make up about 85% of all the mass in the cosmos, yet it does not emit, absorb, or reflect light. It reveals itself only through its gravitational pull on galaxies. We have never directly detected a single particle of it. This fading signal could be the first indirect evidence of dark matter interacting with something other than gravity. The speculative idea is that the particles carrying this radio signal, the photons, are somehow being absorbed or deflected by dark matter as they travel through these dense regions. It would be like watching a car's headlights dim as it drives through a thick, invisible fog. You cannot see the fog itself, but you can see its effect on the light. This possibility has generated a wave of cautious optimism in the astrophysics community. If this correlation holds, it would provide a revolutionary new tool, a way to map the distribution of dark matter across the galaxy by using these hypervelocity stars as moving probes and their anomalous signals as our flashlight. We could, for the first time, begin to chart the architecture of the invisible universe. Yet the caution is immense, the data is sparse, the signal is faint, and the statistical significance is not yet overwhelming. It could still be a complex coincidence, a result of the signal passing through ordinary clouds of gas and dust that just happened to coincide with the predicted dark matter halos. The need for more data is critical. Astronomers are now actively searching for other hypervelocity stars with similar signals, hoping to find more of these cosmic lanterns whose flickering might finally illuminate the dark. Signal 18 arrives as a fractured echo, a message broken by its own journey. When this particular transmission from a hypervelocity star was recorded by multiple observatories, a strange detail emerged. The different colors of light, the various wavelengths that make up the signal, did not all arrive at the same time. The blue components reached our telescopes a fraction of a second before the red components. This is a known phenomenon called dispersion, where interstellar electrons act like a cosmic prism, slowing down lower frequencies more than higher ones. But the pattern of this delay was wrong. It was completely out of sync with the known density of electrons along the star's path. The signal was too spread out, as if it had traveled through a much thicker, more resistant medium than our maps of the galaxy said was there. Astronomers performed exhaustive calculations, feeding all the available data on interstellar gas and magnetic fields into their most powerful supercomputers. They modeled the expected dispersion down to the most minute detail. Yet, when they subtracted this predicted delay from the actual observed signal, a significant anomaly remained. A residual time lag stubbornly persisted, a ghost in the machine that pointed to an unknown factor influencing the light's journey. This chromatic dispersion mystery suggests that space is not as empty as we think, and its effects are not fully captured by our current models. The space between stars might be filled with more than just sparse electrons and dust. One compelling theory posits a sea of very light, weakly interacting particles that we have not yet detected. As light travels through this invisible field, these theoretical particles could impose an additional, subtle drag on certain wavelengths, creating this unexplained dispersion. It would be like light moving not through clear air, but through a faint universal jelly that we can only perceive when we watch a signal from a runaway star get stretched out on its way to us. This is not just a curiosity, it is a potential window into a hidden component of the cosmos, a subtle force that has, until now, remained invisible. The very fabric of interstellar space may hold secrets that only these ultra-fast stellar messengers, with their long, unimpeded paths through the void, can reveal to us. A white dwarf is the cooling corpse of a star, a dense ball of carbon and oxygen slowly fading into darkness. It should be silent, yet one of these stellar remnants, flung across the galaxy at hypervelocity, is broadcasting a complex, structured signal that defies its very nature. This dead star is speaking, and its message has astronomers utterly baffled. The signal is not the simple thermal whisper of a cooling ember. It is a layered transmission with intricate modulations, a data-rich stream emanating from an object that should possess no mechanism for such complexity. The first instinct was to check for a resurrected magnetic field. White dwarfs can have powerful magnetic fields, but they are typically simple in structure, like a bar magnet. This signal suggests a field of impossible intricacy, one that has somehow been re-energized or reorganized. Could the star's violent ejection have triggered a dynamo effect deep within its degenerate core, restarting a magnetic engine that should have been dead for eons? Another natural possibility lies in the star's past. Perhaps this white dwarf cannibalized its own planetary system during its death throes. The resulting debris, a chaotic swarm of shattered planets and asteroids, could now be interacting with the star's magnetic field in a unique way. As metallic asteroids are vaporized in the intense gravity, they could inject charged plasma into the environment, creating a dynamic, signal-generating engine. But the complexity of the transmission strains this explanation to its breaking point. It is too structured, too layered. This has led to a far more speculative idea, one that ventures into the realm of advanced technology. What if the signal is not from the star itself, but from something using it? A white dwarf is a stable, long-lasting source of gravitational and thermal energy. An advanced civilization might use such a stellar corpse as a perfect power source or a camouflaged base. A probe or relay station could be drawing energy from the white dwarf, using its predictable and immense power output to fuel a transmitter, hiding its artificial signature within the expected radio noise of a dead star. The white dwarf becomes a perfect disguise, a silent, dark rock in space behind which a sophisticated piece of technology operates unnoticed. We are left with a profound and unsettling image. Is this the final, sputtering flicker of a natural process we have never witnessed, or are we listening to the hum of a machine, a piece of alien engineering that has hitched a ride on a stellar coffin, using its eternal journey to power a message we are only just beginning to decode? The 20th signal hides in the light the star is missing. Astronomers noticed a fleeting set of dark lines appear in the star's spectrum, sharp bands where specific colors of its light were being absorbed. This was not a permanent feature of the star itself. The lines appeared, lingered for a few days, and then faded away completely, as if something had passed in front of the star, selectively sipping at its light before moving on. The immediate and obvious explanation was a transiting object like a planet or a giant comet. A planet with a unique atmosphere could leave just such a fingerprint, absorbing starlight at wavelengths corresponding to the gases in its air. The hunt began with telescopes across the globe and in space trained on the star, searching for the slightest dip in brightness or any other sign of a companion. They found nothing. There was no dip in the star's overall light, no wobble in its motion, no trace of any object large enough to cause the effect. The absorption lines were a ghost, a signature without a source. This left scientists with a profound puzzle. What could block specific wavelengths of light without blocking the light itself? The leading natural theory suggests a vast, diffuse cloud of complex molecules, a cosmic fog bank composed of hydrocarbons or other intricate compounds. But such a cloud would be incredibly fragile, torn apart instantly by the star's immense velocity and radiation pressure. Its temporary and structured nature defies the chaotic behavior of interstellar gas. This is where speculation takes a dramatic turn. The specific, engineered nature of the absorption lines has made this signal a favorite topic for both serious scientific debate and science fiction. One compelling, though highly speculative, idea is that the lines are caused by a cloud of engineered particles, a smart dust or a swarm of microscopic probes designed to absorb very specific frequencies for communication or propulsion. Even more provocative is the concept of a cloaked spacecraft. The theory posits an object with a metamaterial hull, a technology we are only beginning to explore in labs, which could be designed to render a structure invisible across most of the spectrum. However, perfect cloaking is incredibly difficult. A tiny flaw in the system, a frequency where the cloak is not 100% effective, could result in just this kind of fleeting, selective absorption. We would not see the ship itself, but we would see the shadow of its imperfection, a momentary darkening of specific colors as it passes in front of the star. This signal forces us to confront a truly alien possibility. We may not be looking for giant spaceships silhouetted against distant suns, but for the subtle, spectral ghosts of their passage, the briefest whisper of something hiding in plain sight. A binary system of two stars locked in a frantic dance as they flee the galaxy produces a signal that pulses with the rhythm of their orbit. This is not a simple on and off switch. The pulse intensifies and fades in a pattern that precisely mirrors the time it takes for the two stars to swing around each other, a period of several days. Yet, layered on top of this fundamental beat are harmonic overtones, subtle, higher-frequency pulsations that echo the main rhythm in perfect mathematical ratios. It is as if the entire binary system is a single, immense musical instrument, vibrating not just at its primary note, but also producing a chorus of sympathetic harmonies. In celestial mechanics, an orbital resonance is a beautiful and common phenomenon. It occurs when the gravitational tug between two orbiting bodies creates a stable, repeating pattern. A classic example can be found in our own solar system. 3 of Jupiter's moons, Io, Europa, and Ganymede, are locked in a resonance. For every 4 orbits Io completes, Europa completes 2, and Ganymede completes 1. This gravitational synchrony keeps their orbit stable over millions of years. The resonance in this hypervelocity system, however, is of a completely different order. It is not just the orbits that are synchronized, but the signal itself. The energy output of the transmission is directly tied to the star's positions, pulsing most powerfully when the stars are at their closest approach and fading as they pull apart, all while those harmonic overtones sing along. Replicating this specific, multi-layered pattern with any known natural model is extraordinarily difficult. A simple gravitational interaction could create a basic pulse, but it would be a blunt, messy instrument. The existence of the clean, precise harmonic overtones suggests a system that is resonating with an almost perfect efficiency, a level of coherence that natural astrophysical plasmas and chaotic magnetic fields almost never achieve. The signal's properties point towards a system that is not just behaving but performing. This leads to the profound question of engineering. Could the entire binary pair have been artificially stabilized or even constructed? The idea is staggering. An advanced civilization might use the immense gravitational forces of two stars as a power source, tapping into the orbital energy itself. The harmonic resonance could be a deliberate byproduct of this technology, or even a form of communication, using the fundamental rhythms of gravity as a carrier wave for information. Alternatively, we may simply be witnessing a naturally occurring cosmic instrument of a scale we never imagined, a celestial violin whose strings are the fabric of space-time, played by the gravitational forces of two runaway suns. The faintest whisper in the cosmos is not silence, but the hiss of quantum uncertainty itself. Signal 22 pushes our instruments to their absolute limit, a transmission so quiet it sits precisely at this fundamental noise floor. It is a sea of static that should be completely random, the sound of empty space. Yet, buried within this hiss is a subtle pattern, a faint structure that is just barely non-random, a ghost of order in the chaos. Detecting this required technology that did not exist a decade ago. Quantum-limited amplifiers cooled to near absolute zero to suppress their own internal noise, allowing us to hear the universe's quietest murmur for the very first time. The staggering implication is that the source of this signal is not just faint, but is potentially using the quantum vacuum itself as a medium. It might be employing quantum entanglement to send information, a concept that sounds like science fiction. In this theoretical form of communication, two particles are linked across any distance, and a change to one instantly affects the other. If a civilization could entangle vast numbers of particles and manipulate them, it could imprint a message on this quantum noise, a whisper that is fundamentally secure and impossible to intercept without destroying the message itself. This would be communication not by shouting across space, but by gently tickling the fabric of reality, leaving a trace so delicate that only someone who knows exactly how to listen could ever hope to hear it. The signal challenges our most basic assumptions about information. Are we witnessing a natural quantum fluctuation of unprecedented scale, or are we brushing against the outer edge of a technology that has mastered physics at its most fundamental level? A signal of perfect metronomic precision was logged into the catalogue of new pulsars. Its rhythm was flawless, a steady beat that seemed to mark the spin of a dying stellar cinder, a neutron star. For months, it was just another entry, a cosmic clock ticking away in the void. Then someone checked its location. The signal was not coming from a dense, collapsed remnant. It was emanating from a seemingly ordinary main-sequence hypervelocity star, a type of star that simply cannot produce such a rapid, stable pulse on its own. This was not a pulsar, it was a cosmic impersonator, and its performance was perfect. The discovery threw the field into disarray. How could a star like our own sun, albeit one fleeing the galaxy, mimic the signature of one of the universe's most extreme objects? The immediate and obvious theory was that the star was not alone. Perhaps it had a hidden companion, a neutron star or even a white dwarf, orbiting it so closely that we could not yet resolve the pair. This unseen pulsar would be the true source of the signal, its rhythmic pulses simply hitching a ride on the light of its brighter, faster partner. But deep, multi-wavelength searches found no evidence of a second object. There was no X-ray emission, no telltale flicker in the star's own light, no gravitational wobble. The star appeared to be alone. This forced a more creative line of inquiry. Could the signal be a reflection? Imagine a lone, powerful pulsar located far behind the hypervelocity star, its beam sweeping across the cosmos. If the hypervelocity star was passing through that beam, its atmosphere or a surrounding cloud of material could act like a mirror, catching the pulses and reflecting them toward us. We would see the perfect rhythm, but it would be an echo, a cosmic illusion. The timing and geometry for such a setup, however, are astronomically improbable. It would require a precise alignment across thousands of light years, a chance occurrence so rare it is difficult to take seriously. The most unsettling possibility is that the star itself is generating the signal through a mechanism we have never considered. Maybe its immense velocity is creating a standing shock wave in the interstellar medium, a permanent bow shock that acts as a natural resonator, focusing and releasing energy in these perfectly timed bursts. Or perhaps its magnetic field, stretched and wound by its speed, has organized itself into a configuration that mimics a pulsar's lighthouse beam without the need for a neutron star's incredible density. This perfect mimicry challenges our ability to classify the cosmos. It reveals that the universe can produce identical signatures from entirely different engines, forcing us to look deeper, to question our assumptions, and to wonder how many other cosmic clocks are not what they seem. The 24th signal carries the ghost of a galactic monster. This hypervelocity star's light contains a unique chemical signature, a specific blend of ionized metals and rare isotopes that, until now, has only been observed in the accretion disk of Sagittarius, a star, the supermassive black hole at the heart of our Milky Way. It is a cosmic fingerprint that places its origin at the most violent doorstep in the galaxy. The narrative is almost cinematic. This star was once part of a binary system that wandered too close to the black hole's immense gravity. In a gravitational slingshot of terrifying precision, one star was captured into a tight orbit while its partner was flung away at a staggering speed, ejected on a one-way trip into the galactic halo. The survivor carries with it a permanent scar, the spectral echo of its brush with the abyss. This is more than just a souvenir. The signal seems to contain encoded information about the conditions right at the edge of the event horizon, data we cannot yet decipher. It is as if the star flew through a library of forbidden physics, and its light is now imprinted with texts we have not yet learned to read. The extreme gravity and magnetic fields near the black hole can create matter in states that are impossible to replicate in any laboratory. The echo in the star's light might be our only sample of this exotic physics, a message bottled up from a place from which nothing, not even light, can normally escape. The great frustration is that the code remains unbroken. We can see the signature is there, complex and layered, but its meaning is locked away. Is it a simple record of elemental composition, or does it hold deeper secrets about the nature of space-time itself, warped and twisted just outside the point of no return? This star is a refugee from the galactic center, and its signal is a whispered testament to the violent engine that gave it flight. The final signal is not a sound at all, but a pattern written across the galaxy itself. When astronomers plotted the positions and signal characteristics of all 25 hypervelocity stars on a galactic map, something extraordinary emerged. Individually, each star is a runaway, a cosmic anomaly, but collectively they form a pattern. The frequencies of their signals, their drift rates, and even their ejection velocities align to trace out a subtle, vast geometric shape, a kind of cosmic latticework. It is a meta-signal, a message that only appears when you step back and look at the entire chaotic chorus as one. The immediate, overwhelming implication is that of a network. Could these stars be nodes in a vast, galaxy-spanning communication system, each one a relay station broadcasting not just its own unique story, but also a small piece of a larger data stream, a fragment of a message so immense we have only just noticed its outline? Perhaps they are navigation beacons marking out a hyperlane or a territory, a map for travelers on an interstellar scale. The sheer energy required to establish such a network is beyond our comprehension, suggesting a civilization of unimaginable age and power. Yet there is another, even more profound possibility. What if this pattern is not artificial but a fundamental feature of the universe? The same mathematical constants that govern the shape of a snowflake or the spiral of a galaxy might also dictate how stars are ejected from the galactic core. The forces that create hypervelocity stars could be weaving this pattern naturally, a deep structural resonance in the laws of physics that we are only now glimpsing. This meta-signal forces the ultimate question. Are we seeing the first evidence of a cosmic architecture, a designed framework underlying our galaxy? Or have we simply stumbled upon a new law of nature, a beautiful, complex symmetry that has been hidden in plain sight all along? The answer lies in the silent spaces between these 25 messengers, a secret waiting in the collective shape of their flight. These 25 signals are not a single mystery but a chorus of them. Each one challenges a different pillar of our understanding, from the fundamental particles that make up matter to the very laws governing gravity and motion. The rhythmic pulse defies our catalogues of stellar death, while the drifting frequency hints at forces that operate with patient, unseen deliberation. The prime number sequence questions the very nature of coincidence, and the coordinated neutrino burst reveals a unified cosmic engine we cannot yet name. Together, they form a tapestry of enigmas, proving that the universe is not only stranger than we imagine, but stranger than we can imagine. This is the humbling and exhilarating reality of modern astronomy. Our maps of the cosmos are still being drawn, and these runaway stars are illuminating the blank spaces, the edges where our knowledge ends and pure wonder begins. The search is far from over. New telescopes both on the ground and in space are now turning their gaze toward these cosmic messengers, listening more intently than ever before. The greatest discoveries lie ahead, so we turn this question over to you. After this journey through the unknown, which of these 25 signals captured your imagination the most? Was it the silent white dwarf that spoke, the star with the impossible infrared glow, or the meta-pattern written across the galaxy itself? Share your thoughts in the comments below, and if you are ready for more journeys to the edge of understanding, be sure to subscribe for our next deep dive into the cosmos's greatest enigmas.